Let's take a look at the Unit 9C. What we're supposed to get out of the advanced section and the station rotation, which if you look is all review on this. So going back over things, Unit 9C was about determining when a function is a quadratic so that we would be able to do the Unit 9B stuff to it. Okay, so we want to review multiplying polynomials, and then we're going to work on factoring quadratics as well. So in our multiplying of polynomials, we use the area models. We use the area models for factoring as well. But in this example, I'm going to, first of all, I got 3 parts. So I'm going to multiply these two together first. That's kind of what I have set up here. I have one monomial, so that's a 1 tall box, and a binomial, so that's a 2 wide box. That way, and 2 times 2 is 4. That's 3 x's in there and a minus 6x squared. So this, in its first stage, becomes a 4x cubed minus 6x squared times the x squared plus 3x minus 5. So that's a binomial times a trinomial. Binomial takes a 2 high box. So we'll load the 4x cubed and the minus 6x squared onto there. My trinomial was the x squared plus 3x minus 5. So that gives me a 4. 3x's from there, 2 from there is x to the 5th. 4 times 3 is 12. X, 3 of them there, 1 of them there, that's 4. X to the 4th. 4 times negative 5 is negative 20. And I got an x cubed there. Here I got a negative 6. 2 from there, 2 from there is 4 x's. Negative 6 times 3 is negative 18. 2 x's there, 1 there, that's an x cubed. Negative 6 times negative 5 is a positive 30. And an x squared. So my final answer is 4x to the 5th. I can combine these. 12 minus 6 is 6x to the 4th. I can combine these. That's minus 38x cubed. And then I have a plus 30x squared, which is a quintic. It's not a quadratic. So identifying A's, B's, and C's is meaningless in this case. So wouldn't be able to help me with learning about that. We learn about polynomials like this in Algebra 2. Okay? So, on these other ones, multiplying and simplifying, monomial, binomial. So that's a box that looks like this. Monomial is the 2x. This is a 3x minus 1. So 2 times 3 is 6. X and x is x squared. Negative 1 times 2 is negative 2 and an x. And so this just becomes a 6x squared minus 2x. In standard form, that is a quadratic because the leading term is quadratic. And so because it's quadratic, I should know then how to find its axis of symmetry and its vertex and its y-intercept and another point that is on there I can now identify the a's. I would say in this case a is 6. And B is negative 2, and C, since there's nothing added on there, it must be a 0. Okay. And I could continue on from there if I was doing that part of this. All right, x minus 3 squared. When I square something, it means multiply that by itself. So I'm going to need a square to multiply that by itself. It's x minus 3 and x minus 3. It's a literal square. The sides are exactly the same on there. I can even symbolically say this is the negative 2 times x minus 3 squared plus 6. And so this becomes an x squared, and that's a minus 3x. And that's a minus 3x, and negative times negative is a positive 9. So this looks like negative 2 times x squared. These are like terms. Negative 3x minus another 3x is minus 6x plus 9 plus 6. Distribute this -2 through there, which if I wanted to, I could use an area model for that too. It's a monomial times a trinomial, so x squared minus 6x plus 9 gives me a -2 from there, x squared from up there, positive 12 and an x and a minus 18. So this is now looking like negative 2x squared plus 12x minus 18, and I still have this plus 6 that I haven't dealt with yet, but those are like terms, so I can put those together and get negative 2x squared plus 12x. You notice if I don't put them together, then I wouldn't correctly identify what the c was when I was trying to find what the y-intercept is, okay, or some other things that we're going to do with that later. So that's what that needs to look like at the end. Okay, got that one up there. Okay, this one I've got binomial times binomial minus binomial times binomial. Well, binomial times binomial means I need 2 tall, 2 wide box, 2x minus 7, 4 minus 3x, and I'm going to subtract from that the results of, didn't leave myself a lot of room there, 2x minus 1 and 2x plus 1. So this gives me an 8x. That's a minus 6. X and x is x squared. 4 and negative 7 is negative 28. Negative 7, negative 3 is positive 21, and there's an x from there. 2 times 2 is 4, and that's an x squared. 2x times 1 is 2x. 2x times minus 1 is negative 2x. Negative 1 times positive 1 is minus 1. And so this gives me a, writing it in standard form for this part, negative 6x squared. These are the like terms this time. That's a plus 29x and minus 28. And I'm subtracting from that 4x squared. Here are my like terms. 2x minus 2x is nothing. And I've got a minus 1. So this minus needs to change the sign on all of those, and I get a negative 6x. That was supposed to be squared, right? Negative 6x squared plus 29x minus 28 minus 4x plus 1 minus 4x squared plus 1. So I've got a minus 6x squared and minus 4x squared is negative 10x squared. That takes care of those. I only have one that has an x in it, so plus 29x. And negative 28 plus 1 is negative 27. So this now looks like that, and I would be able to identify my a's, b's, and c's again to locate the axis of symmetry and the vertex and the y-intercept, okay, and another point that was on the graph. All right, so that's that direction, okay? Giving something that's got the parentheses in it in a factored kind of form, multiplying it to get rid of the parentheses so that I can get a standard form out. Okay? Now, when my quadratics are in a standard form, it's nice. It doesn't always work, but very often it does work that I can break them up like we did in our level up game. Okay. I'm going to try to figure out what this looks like if it was written like this. And the area model is my in-between that's going to help me get there. So I know the 4 goes here, and the x squared goes there. Cheat code number 1, 4 times 1, I'm looking for numbers that multiply together to give me 4, but add together to give me negative 5. Okay. And cheat code number 2, if I needed it, I can make a 1 times a 4. It's got to be positive, that's got to be negative, so they both have to be negative, and negative 1 plus negative 4 is negative 5, so that's exactly the one I need, a negative 1x and a negative 4x. I'll load those in here. That'll be an x, that would force that to be a negative 4 and that to be a negative 1. So I would have an x minus 1 and an x minus 4. Being able to do this is going to help us in standard D. Okay, so 9x squared minus 4, let's do that one as well. So here's the 9x squared and the minus 4. I need numbers that 9 times negative 4 multiply to negative 36. There is no linear term in here, so they have to add to 0. Okay, if I go the long way on my cheat code again, to get 36, I could do 1 times 36. I know one of them's got to be negative because the product is negative, but 1 minus 36 is not 0. 2 times negative 18 would make a negative 36, but adding those gives me a negative 16, not 0. 3 and negative 12 gives me negative 9, so that's not it. 4 and negative 9 gives me negative 5. 5 doesn't go nicely into there. 6 and negative 6 works, and 6 plus negative 6 is 0, so I have a negative 6x and a positive 6x in this. Right, multiplying there, adding there. Greatest common factor there is a 3x, which means this also has to be a 3x. This has to be a minus 2, this has to be a plus 2, so this factors into a 3x minus 2 times a 3x plus 2. Okay. And then finally this one. Let's see, 5, 6, 7, so no greatest common factors there. Always want to remember to look for that if it's there to get smaller numbers, because these numbers look a little bit on the big side. So 12x squared and minus 9. 12 times 9 is 90 and 18, negative 108. And they need to add to 52. So let's try some things out. One positive, one negative, and the positive one's got to be bigger. Okay. So 1 and, or negative 1 and 108 gives me 107, not that. 2, negative 2, and 54 gives me negative 108, and 54 minus 2 is 52, so that's the one I need. I'll throw a minus 2x and a plus 54x. Greatest common factor here is a 2x, which means this must be a 6x. 6 times 9 is 54. Minus 1 there. Negative 1 times 9 is negative 9. That works. So this must be a 6x minus 1 and a 2x plus 9.